Hi everyone, so in this video today we're going to try to solve a differential equation, particularly second order differential equation. Okay, so before we do that, let's recall first order differential equation. So you have your first order differential equation as ANX dy dx plus A naught y equals to gx. Okay, this is first order. Okay, how do you know? Your derivative is just y prime. Okay, this is just y prime. Now you can have second order. It is your equation, differential equation given as this. The second derivative plus a1x dy dx plus a naught x y equals to gx. Okay, if you look at here, this is y double prime. So this equation here is my second order differential equation. So gx is given as a function. Okay, gx is a function. Now we say that if gx equals to 0, then you have homogeneous equation. Then if gx is not equals to 0, not 0, okay, and then you have the non-homogeneous equation. Okay, these are some basic principle or thing that you need to know about differential equation. Okay, so the other thing that I want to say is that the second order differential equation given here, you can have an initial condition. So my initial condition is given at y and x naught equals to y naught. Okay, or the O is very small. Okay, this is initial condition. You can have more than one initial condition. Okay, inside here is my x and equals to y naught. Okay, so if you have a problem plus initial condition, you have initial value problem. Okay, so for instance, I can have a problem such as y double prime plus 3y prime plus 4y equals to 0, y 0 equals to 1. Okay, so this is my initial condition. This is my problem, my second order differential equation, my second order homogeneous differential equation. So I have initial value problem. Okay, so the other thing is that I'm going to say you can have more than one condition. So if I have a problem and boundary condition, okay, problem plus boundary condition, then you have boundary value problem. Okay, so boundary value problem, example boundary value problem can be given as y double prime plus 4y prime equals to, let's say, 0. So given at y0 equals to 1, y1 equals to 2. Okay, this is boundary condition. Now why this is boundary condition? Look at the condition given here. Okay, so you have my x naught equals to 0, and you have my x naught equals to 1. Okay, the x is from 0 to 1. So you have, this is called boundary condition. Okay, so these are some terms that you need to know before solving a second order differential equation. The other thing that we want to know is the unique solution. Okay, is there a unique solution? So that's what we want to look at next. So what is a unique solution of an initial value problem? So a unique solution simply means, if let's say we have a continuous for the constant, let's say we have a n x, a n minus 1x, these are the coefficient, a1x and a0x. Okay, I'm talking about a differential equation in this form, a1x dny over dx squared plus an minus 1x dn minus 1y over dx n minus 1 plus a1x dy dx plus a0 xy equals to gx. Okay, so I'm talking about this higher order. We say higher order because it depends on what the value of n. Okay, let's say we have this. So for the coefficient here, an minus 1, a1, it must be continuous on the interval given. Okay, it's continuous on an interval I, and let an x cannot be 0. Okay, so this one here cannot be 0. And then if x equals to x naught any point or interval, then the solution to this initial value problem exists on the interval n unique. Okay, so let's look at one example here. So we have this example here. Determine whether the initial condition or the initial value problem given below has a unique solution. Okay, so how can you know whether it has a unique solution? So we need to look into the definition of a unique solution. Okay, so first thing we want to make sure the an is not equals to 0. So given like this, 3y to the 3 plus 5y double prime minus 7y equals to 0, and the initial condition y1 equals to 0 and y prime 1 equals to 0 and y double prime 1 equals to 0. Okay, before we answer this question, this is initial condition. It's not boundary. Okay, because the x naught here is 1, 1, 1. The x interval is just start from 1. There's no 2x interval. Okay, so this is initial condition. Now, how to know whether there's a unique solution here? First, we see that this is my A3, this is my E2, okay, my A1 is 0, and this is my E0. Okay, we have A3 equal to 3, A2 equals to 5, A0 equals to negative 7, and A1 1 equals to 0. Okay, so we say that for the solution to be unique, okay, this thing here, a and x cannot be 0. Okay, so my a and x is my a3, so we know that my a3 is not equals to 0. Okay, and then for x equals to 1, so for x equals to 1, it said that there must be a continuous, the interval must exist for x value. So for x equals to 1 in here, it's continuous. Okay, therefore we say y equals to 0. Okay, therefore we say that y equals to 0 is the only solution on interval x equals to 1. Okay, this is my x, these are the y value. Okay, so y equals to 0, y equals to 0 is the only solution on the interval I equals to 1. Okay, so this is how you determine whether the solution is unique. So we can look at another example here. Okay, so verify. Okay, so we'll say for the given differential equation, this one, cot xy equals to x squared plus 1, we have a non-homogeneous equation, and the condition given as y2 equals to 11, y prime 2 equals to -2. So show that the solution here is unique. Okay, solution. So we want to show on which interval the solution is unique. So if you're given a question like this, first thing you need to arrange it in the standard form. So the standard form gives y double prime, divide everything by x plus 2, y prime plus cot x over x plus 2, y equals to x squared plus 1 over x plus 2. Okay, so we want to divide by x by 2. So this is my an here. Okay, so when we divide this, then what we have here, we know that the solution is unique because my a2x equals to 1. Okay, this is for this part here. Okay, for this part here, we know that my x cannot be -2, sorry. X cannot be -2. Okay, because if x is -2, then you have this term here, discontinuity. Okay, we cannot divide by the denominator, so x cannot be -2. But for x equals to 2, the given is x equals to 2. So the solution exists. Now cot discontinuity occurs when cot is 1 over tangent. Okay, this is 1 over tangent x, right? So discontinuity occurs when x is 0, -2, because you're going to divide by 0, and then plus minus pi, 2 pi, 3 pi. Okay, but for this value of x, the interval that contains x equals to 2, okay, we have discontinuity occurs, -2, right? So therefore, we will say that the solution exists on this interval. Okay, so x can be 0 to anything in between 0 to pi, or my pi is 3.14 something. Okay, so the question is to verify the unique solution exists and on what interval. So I will say anything, because anything from this, the graph of chord x, 0. So this is 2 here. So anything from here should give you the largest interval. So we'll take from 0 to pi, gives you the largest interval. Okay, so that's how you find the unique solution. So you have to determine whether my A exists. It's not equals to 0, the constant in here. Okay, we can look at one more example. So the example is, let's say like this. Okay, so verify that x2y double prime minus 2xy prime plus 2x equals to 6 for y0 equals to 3 and y prime 0 equals to 1 has no unique solution. Okay, how can we say that the solution does not, the solution is not unique? Okay, so let's look at the second derivative here. Minus 2xy prime plus 2x equals to 6. This is my second derivative here. Okay, when x given here, this is my x. X is 0. So when x is 0, what happened to my a2? Gives me 0. Okay, because a2 gives you 0. So, and the other thing is, if I divide all by y squared, okay, let's look at this. Y double prime minus 2xy prime over x cubed plus 2x over x squared. I'm writing in the standard form. Okay, so look at this. What happened when x is 0? So I cannot divide by 0. So I cannot divide by 0. No solution exists here. Okay, you cannot divide by 0. It is impossible for you to get this solution here. So we can say that no unique solution. Okay, so that's how you find existence of a unique solution. Okay, so let's move on to something what we call superposition principle. Okay, so we want to look at what is superposition principle. Superposition principle is also important when you are looking at solving higher order differential equation. Okay, the superposition principle says that the sum or superposition of two or more solutions is homogeneous linear differential equation. So for instance, I can say that let y1, y2 up to yk be a solution of the homogeneous. It has to be homogeneous nth order differential equation. Okay, let this is the nth order differential equation. Then the linear combination. Okay, we have the linear combination such as y equals to c1 y1 x plus c2y2x plus r2ck_yk(x) is also the solution. So when we can write in this form, we have this superposition principle. Okay, so for example, if k equals to 2, if we choose k equals to 2, then I have y equals to c1y1x plus c2y2x when k is 2. Okay, so we can write that, and we can say that the solutions are the y1, y2 is the solution for the homogeneous equation. So we let them to be the solution, and then we see whether they can give the solution. Okay, for instance, let's look at this example here. One example show that we want to show whether the solution, the y1 and y2 is the solution. Okay, so show that y1 equals to x squared and y2 equals to x squared ln x are both solution of the homogeneous linear equation. From this equation, y triple prime, x triple prime, the third derivative, minus 2xy prime plus 4y equals to 0 on this interval given here. Okay, how can we show that y1 equals to x squared and y2 equals to x squared ln x are both solution to the homogeneous linear equation? So this is where your superposition principle must hold. Okay, so we start with writing let y equals to up to can write, we have two, y1 and y2, so I can write c1y1 plus c2y2. Okay, we have to differentiate this y up to third derivative. So we have y prime equals to, sorry, before that let me just put it in the y values first. So y equals to c1, y1 is x squared plus c2, y2 is x squared ln x. Okay, so now I can differentiate with respect to x. I have 2x c1 plus c2. I need to use the product rule here. This is u, this is v. So we have u dv dx, ln x gives you 1 over x, plus v du dx, this is my 2x. Okay, let's simplify this first. 2x c1 plus, cancels out one term, c2 x plus 2x ln x. Okay, now taking the second derivative gives 2c1 plus c2, 1 plus, taking the product rule again, u dv dx plus v du dx, I get 2. Okay, this is the second derivative. Okay, now I can simplify this first. 2c1 plus c2, 1 plus, what is this, 2 plus 2 ln x. Okay, simplifying, I have 2c1 plus 3 plus 2 ln x c2. Okay, now we have to take another, the last third derivative. which gives this 0 and this one 2 over x. On x is 1 over x. So we have 2 over x c2. Okay, now we have to put into all this derivative obtained to the given third order differential equation. x3 y triple prime minus 2x y prime plus 4y. Okay, I will show that whether I can get 0. Okay, so I have x3. Now y triple prime is 2 over x c2 minus 2x, and y prime is this 2x c1 plus c2x plus 2x ln x c2 plus with 4y. Y is c1 x2 plus c2 x2 ln x. Okay, can I get them 0? If I can get 0, then I can say y1 and y2 are the solution. Okay, so I have 2, this is x2, so 2x2 c2, cancel with 2, so we have c2 here, x here, x squared c2. Okay, this term cancels out. This is 4x c1 minus and plus cancels out with this term, 2x squared ln x. 2 times 2, 4x squared ln x. This is 4x squared ln x. Okay, cancels out, so we get 0 here. So therefore, I can say that y1 and y2 are the solution to the given differential equation. Okay, so we don't have much time now, but what we can do, okay, I'm going to give you some homework. So try to do this exercise here. So you have your exercise. Okay, please submit this exercise. So the first question is, show that y1 equals to cos x and y2 equals to sin x as solution of the differential equation y double prime plus y equals to 0. Okay, use the superposition principle here. Now the second question, given that y1 and y2 are the solution of the differential equation, y double prime plus y squared equals to 0 is y3 equals to c1 y1 plus c2 y2 is also a solution of the DE differential equation. Okay, that's number 2. And lastly, the third exercise here, show that y equals to exponent 7x is a solution of y double prime plus 9y prime plus 14y equals to 0. Okay, so submit your exercise on my Guru. So that's all for today. So we'll look at you the next topic. Till then, see you.